Alright guys, so I'm going to quickly show you how to solve a rational equation using DESMOS. So we've done equations before, and all you simply need to do is take the left side and set it equal to the right side by splitting it up. So I'm going to pull this over a little bit. So this is going to be y equals, make sure you always do y equals 6 divided by x squared plus 5x minus 66 minus, and 3x divided by x plus 11. And then the right side is negative 3, so we're going to come down here and do y equals negative 3. And then you simply look for the intersection of the two graphs. So if I look for the intersection of the two graphs, there's one here, and it's always the x value. You should notice that we have one at 5.818. If I kind of zoom out, I should see that honestly with this line right here, it kind of looks like the horizontal asymptote, but I can continue to pull it and zoom in and kind of test it out if I need to. But if you continue to scroll, you should see that they're never going to actually intersect on this side, which is the left. And then I can do the same thing with the right and see that they're never going to intersect on the right as well. So the solution to this problem is where the two graphs come together, which is at 5.818. Alright, and for this one more problem, we're going to look at this equation right here. So we're going to take this equation and we're going to plug this into DESMOS just like we did before. So basically we're going to put the left side in, so we have y equals 2x plus 3 over, and then we have x minus 1. And then we have the right side, which is going to be y equals 10 over x squared minus 1 plus 2x minus 3 over x plus 1. Now it's going to look like there's a lot going on, which there is, but you're looking for the intersections themselves. Okay, so if we notice on this side, it's never actually, it's hitting a horizontal asymptote, so that's never going to touch there. Alright, so then we come over here and we're looking for where it hits the x-axis. That's never going to touch there either. Now there is a point that pops up here, but that's not the point of intersection. And then we see that it's never going to hit here. And then we're going to go further down and we see that they're going to line up, but they're never actually going to intersect. So this one actually has a no solution because there's never any intersections here with these particular points. So now we're going to look at this last one. So we have y equals 7 plus, and then we have x over x plus 3. And then on the right side we have y equals 9 over x cubed plus 3x, and we're looking for the intersection. So I obviously see an intersection here, so you're looking for the y value. So there's a solution at 0.4, and then there's another intersection here, which is at negative, excuse me, not the y value, the x value at negative 2.64. So the solutions are always going to be the x values. Alright, I'm going to zoom out just a little bit to make sure there's no more intersections. And I can see that there is not. We're going to look up here. You can see that this one's kind of hitting a vertical asymptote there. So this one has two solutions at negative 2.64 and at 0.4.